So here is my boat. On the left we have a little debug thing which will tell us the current acceleration of the boat. When we hit W, the boat will begin to accelerate. As you can see, the velocity is slowly increasing. It's reached the maximum velocity possible with this acceleration. Increase it again, accelerates a bit and has reached the maximum velocity. We can accelerate further and increase higher velocities. We can decrease acceleration and go to lower velocities. We can also rotate and turn around this buoy at the end of the path. As you can see there's a little bit of drift as the movement in one direction slowly changes. Let's see if we can go faster and show this off a little bit more. So as we see, we're drifting in the X direction. There we go. And there's some simple things about the game. Now, first we're just going to have a quick look at some of the classes we have. So here is the buoy class. As you see, we have the position in a vector. Also have the draw and the draw start functions, as well as a function to change the position of the buoy. Now if we look, the buoy position function simply changes the position of the buoy to the given inputs. If you look at the draw start, it will draw a simple polygon. So in this case, it is used to draw the start line. So it's quite a wide rectangle, as shown by the -40 to 40, so 80 wide and 3 tall. Now, to draw the buoy, we use a triangle strip for the square initially. Fairly simple. We loop it around and then we loop it underneath, just to give it a full 3D effect. We then draw the pole, so again it's just another triangle strip, and we draw the 4 different sides, and then we use the bell at the top or the end of the pole. So this is just a simple solid sphere at the top of the pole. It's important to note that we use push matrices and pop matrices. What this does is the push matrix takes a saved copy of the scene as is, taking the location of all the objects. We can then translate to the correct position for when we want to draw something. So in this case we translate to the position of the buoy and translate it up by 10. We then draw the sphere, and then when we use pop matrix, all the stuff that was saved from the push matrix will return to where it was, whilst the things we've drawn since then will stay where they are, so everything is correctly drawn in relation to each other. Now we look at the boat. The main thing we need to look at here is displacement and rotation. So the rotation just keeps track of the rotation of the boat, which we will then use when we draw, such as when we draw the prow, to make sure that the prow is rotated to be in line with the boat and the same way that we would accelerate. We also translate using displacement to make sure that the boat is in the correct place. For the prow, we also translate in the X direction slightly, so we have 2 distinct prows at the front of the boat. We use triangle strips to draw parts of the boat, as it can give a relatively complex shape rather easily. We also draw a heading line, so we can see which way we are facing and where we are going to go when we accelerate. All of these use push and pop matrices just to move them about in relation to the scene. In the int main, this is the main function, so this is what the code will run in the beginning. We start off by setting all the settings for the things such as the window size, the position, the name of the window correctly, as well as the display mode. So we use a double buffer. Otherwise there's some issues with frame rate and the boat doesn't move anywhere near as fast as it should, or there's significant input lag. We also have the important draw scene function. So if we go up to our drawing scene function, we see that we set the matrix mode to model view, so that this makes sure that we are drawing what we want. We use the look at to move the camera and then make it look at the player. We also change the color here. Because OpenGL is a state machine, if you change the color, everything you draw from that point forwards will be the color you say until you specify a different color. So here we are specifying blue, as the three values relate to red, green, and blue, as in the RGB color scheme, and the values go between 0 and 1. So for empty or full, we then start drawing a very simple square with very large dimensions. This will be our C. We then change the color so everything isn't blue, because if everything was blue, we wouldn't be able to see it, as there is no lighting in this game at the moment. This here is a comment just to help with debugging. So if I'm trying to work out why triangle ships aren't drawing the way I think they should, if I make this into actual code and remove the comment, it will change how OpenGL draws the shapes. So it won't fill them; it will just draw the individual lines. This will this can help show where the triangle strips or other things are going wrong. Draw the boat and the start line. They will both be green, as that is what is set in the RGB. In fact, I believe part of the draw boat function changes something to be red, so the start line will actually be red as opposed to green. Then, using this for loop, we draw two lines of buoys, each with each 40 units apart in the Z direction. We then also draw a final buoy at the end that we can use. Every size, we set the basic, so some of the basic settings. Most importantly is the loop perspective. This tells the camera the basic attributes of how it will look at the scene. And also in our main game loop, so every update, it will redraw the scene to make sure that it's drawn at its currently updated position. I would like to briefly talk about the axes in OpenGL. So OpenGL uses the right-handed rule, which means that if you stick your thumb out, your index finger out perpendicular, and your middle finger perpendicular to both of those, you get an idea of where the axes are in OpenGL. So firstly, your thumb is the X direction, your index finger is the Y direction, and your middle finger is the Z direction. This normally means that X is to the right, Y is up, and Z is towards you. However, in my game, I've rotated this 180 degrees so that Z is away from you, Y is still up, and X is to the left as opposed to the right.